Which of the following statement is correct or of adiabatic process? We know that for adiabatic process, molar heat capacity is 0. Why molar heat capacity is 0? You know about molar heat capacity means heat energy won't be given to the system or it won't be taken out from the system. So Q itself 0. That's why A is correct. B. Molar heat capacity is infinity 0. Work done on the gas is equal to increase in, we know Q is 0 or the work done will be equal to minus U because Q equal to U plus W. We know the formula. So this case, work done will be equal to increase in internal energy is correct. So work done by the system is equal to increase in internal energy is correct. The increase in temperature results in a increase in temperature will increase the internal energy. And temperature increase and internal energy also will increase. So here the answer is A and C are correct, is the correct answer. Okay. 2 point charges Q and 9Q are placed at a distance R from each other. Then the electric field is 0 at a point. So we have a charges Q1 is Q. Another charge is 9Q are separated by a distance R. We wanted to find out the electric field is 0 at a point. So we wanted to find out where the electric field is 0. In a point, let us assume that point as 0. And here it is X in vachitena from Q. Inga R minus X. We know that up in the point, like if you wanted to find out electric field at a point, keep a unit positive charge. And this also positive. E1 will be in this direction. Let us assume E1 is due to plus Q. And plus 9Q, let us take it as E2. And that will be plus and plus will be E2 will be in opposite direction. In other words, electric field due to Q should be equal to electric field due to 9Q. That's all. So we have taken the direction and we wanted to find out the distance. Electric field due to point charge, we know that K, Q by, we assume this distance as X squared equal to K 9Q divided by R minus X the whole square. Okay. K gets cancelled, Q gets cancelled. All the numbers are, we can take square root. 1 by X is equal to 3 by R minus X. Cross multiply 3x equal to R minus X. 4x equal to R. X will be equal to R by 4 from plus Q. The distance R by 4 from plus Q. R by 4 from plus Q is the answer. Okay. R by 4 from plus Q. We'll go to the next question. In the question, the moment of inertia of a uniform rod of mass m, length L, alpha is I. Moment of inertia of the rod is alpha. Okay. When rotated about an axis passing through its center perpendicular to the length, it's given. This is a rod whose length is L. The moment of inertia about the center will be, we know that, ml squared by 12. So they have taken alpha is ml squared by 12. This is the first part of this problem. Okay. Now the rod is broken into pieces. So this is 1 L by 2 and L by 2. Equal half arranged as shown in the diagram. The moment of inertia of the given axis is very simple. Here this one is L by 2, this one is L by 2. What is the moment of inertia about the center? Let us take it as net moment of inertia is I1 plus I2. I1 and I2 are equal. Both are half the length. What is the moment of inertia of the after it splits? we know the mass become m by 2. L become L by 2 the whole square. L by 2 the whole square. By 12, we know the value. This is the general formula for moment of inertia of the rod of length, half the length of the original. Okay. So what happened to the new moment of inertia of one rod is m L squared by 2 into 4 into 12. So 2 into 4 into 12. This is the moment of I1. I1 and I2 are equal. So this can be written as net moment of inertia about the center will be 2 times I1 போட்டலாமா? Or 2 into this value ml squared divided by 2 into 4 into 12. Here this is gets cancelled. But net moment of inertia is ml squared by 4 times 12, nothing but 48. We wanted to relate with the alpha. So alpha is nothing but ml squared by 12. Upon 1 by 4 ml squared by 12 is nothing but alpha. So the answer is alpha by 4 is the answer. Okay. A square shaped lamina of mass m kg is rest. Find the value of F in Newton. We have a diagram. This diagram. In this corner, there are two forces. This corner also two forces. Whereas this is a fixed point, we wanted to find out this value. Okay. So it is clear these two forces, 10 Newton and 10 Newton, will give you a resultant force this direction. And that force is cancelled by this fixed point. So we no need to worry about this force because it's fixed. Similarly, here these are the two forces whose resultant is, what is the resultant of these two forces? Fr equal to root of 100 R1 squared plus R2 squared 100, 10 squared, or we'll write it as 10 squared, no problem. So this is 10 squared plus 10 squared. So it is nothing but 100 plus 100, 200, root of 200, which is nothing but 10 root 2 Newton is the resultant force. So this should be act in this direction. But this force should be 10 root 2 Newton. Then only the body will be in rest. Here, it is clear 10 root 2 should be the resultant of 10 Newton plus this F squared. Now you wanted to find out F. That's all. So squaring both sides, 100 into 2 equal to 100 plus F squared. F squared can be taken out. F squared equal to 200 minus 100, 100. F is clear, 100 Newton is 10 Newton is the answer. So it is clear, this force is 10 Newton. Relation between magnetic susceptibility and magnetic permeability. So susceptibility is chi-m, magnetic permeability is mu. Actually, we have a relation mu r equal to 1 plus chi-m. Mu by mu naught equal to mu naught into 1 plus chi-m should be the answer. This is not here. So, but they have given this relation. First relation is given. Mu r is called not magnetic permeability. It is magnetic relative permeability. So this is the answer that we can able to take. None other, because here 1 minus im, 1 plus im is the answer. Here mu naught, there is no relation. Mu 1 plus, this is the mu value. Mu equal to mu naught into 1 plus im can be written. Okay. So the answer is 2. Okay. In the question, Papa, the ratio of magnetic field at the center of the circular coil to magnetic field at distance x from the center of coil is x by r equal to 3 by 4 கொடுத்திருக்கு. அப்போ let us take it as magnetic field. The center of the circular coil is mu naught I by 2r. This is magnetic field at the center. Axis formula, let us take it as B2 mu naught I x squared, because the distance is taken as x squared, into 2 into x squared plus r x squared plus r squared to the power of 3 by 2. So it is clear x is equal to 3 by 4 r. Now, instead of x, I am going to substitute this value. Okay. So r squared plus x. Anyway, this is also correct. So mu naught I, instead of x, I am going to substitute the value as 3 by 4 r squared. This is r squared. Small mistake in this. This is r squared. Okay. Mu naught I r squared divided by here 2 into x is equal to 3 by 4 the whole square. 9 by 16 r squared plus r squared to the power of 3 by 2. You can take r squared common. R squared to the power of 3 by 2 is nothing but r cube. When you take it out as r cube, அப்போ mu naught அந்த r cube இந்த r squared போயிடும். So mu naught I by 2 into r into 1 plus 9 by 16 to the power of 3 by 2. That's all. Okay. Now we'll go proceed. This is equation number 1. Let it be equation number 2. And mu naught I by 2r is nothing but B1. A new magnetic induction will be equal to second case B divided by, or B1 divided by, which is equal to cross multiply 16 plus 1, 17 plus 9, 16. So approximately 17 plus 9, 26 by 16 to the power of 3 by 2. Okay. We wanted to find out B1 by B2. But this is B1. But B1 by B2 is equal to cross multiply pantamna B1 by B2 25, approximately 25 by 16 to the power of 3 by 2, which is already we have taken square. Here we have taken no. Already we have taken the square, no? So only to the power of 3. Only to the power of 3. Up, here already this is the term r squared can be taken out as okay 3 by 2. Okay, 3 by 2 correct up. 3 by 2. This also 3 by 2. Up, here when you take cube root, square square root 4 to the power of 3, which is 125 by 64 is the answer.
The question, find the electric force on a point charge Q. It is given, there are two charges. There is a charge placed in between the two plates. Actually, it is not a linear charge density, it's a surface charge density. So plus sigma and minus 2 sigma, two sheets are there. So we wanted to find out what is the force on this charge. Okay. To find out, first நம்ம இங்க எலக்ட்ரிக் ஃபீல்ட் என்னன்னு பார்த்துருவோம். We know electric field due to plus sigma is, this is Q and positive, so the direction of the electric field is, let us assume it as E1. This is the electric field at this point. What about this? This is minus, and here also the same electric field, but the value is E2. It's a vector quantity, so we have taken the direction because positive charge is attracted towards a negative plate. Okay. So the net electric field will be equal to E1 plus E2. In the point, net electric field is E1 plus E2. We know E1 is nothing but sigma by 2 epsilon naught. This is the electric field due to a single plate. Whereas here the plate is having a charge 2 sigma. So it becomes 2 sigma by 2 epsilon naught. So the net electric field will be equal to 3 sigma by 2 epsilon naught. That's all. Now we want to find out force. Force on a charge in an electric field is EQ. E is 3 sigma by 2 epsilon naught into Q. This is the correct answer. So 3 sigma Q by 2 epsilon naught is the correct answer. Okay, the question, match the column, coefficient of viscosity and the dimensional formula of these vector. Coefficient of viscosity, you know the formula, stress by velocity gradient. Stress is nothing but force by area, velocity by length. Force mlt to the power of minus 2, area L squared, lt to the power of minus 1 by L. Cancel, LL gets cancelled. This L also gets cancelled. So ml to the power of minus 1, t to the power of minus 1 is a dimension. So A corresponding to 2. So A corresponding to 2, upper 3 or 4 is the answer. So 1 and 2 is ruled out. Okay. And pressure gradient. Pressure gradient is nothing but pressure by length. Pressure is nothing but force by area by length. Force is mlt to the power of minus 2 by L squared into L. Okay. 1 L gets cancelled. Up to M, L to the power of minus 2, T to the power of minus 2. So pressure gradient is ml squared T to the power of minus 2. 3, B is 3. So B is 3. This is also correct. This is also correct. Okay. Next, compressibility. Compressibility is nothing but reciprocal bulk modulus. Compressibility is nothing but reciprocal bulk modulus. Bulk modulus is force by area by force. Upon area L squared, force is mlt to the power of minus 2. So the dimensional formula is 1 L gets cancelled, m to the power of minus 1, L t to the power of 2, m to the power of minus 1, L t squared. So compressibility is 1, C is 1. So this should be the answer. Both option is the correct answer. Here, some other answer comes. So this is the correct answer. Okay.
The figure shown in an infinite plane having uniform charge density sigma and a small charged particle, okay, having a charge q and a mass m is suspended by a light insulating thread. Find sigma if the charge is in equilibrium. It's clear. Here we have a plate. This is a sheet, not a plate. Actually, it's a sheet having charge density plus sigma. Here the charges are uniformly distributed plus sigma. Okay. Here we have another charge. It is suspended in a simple rope. Now, actually, before that, the weight was acting downwards, which is mg. After the electric field is applied, there is a force, which is force due to electric field, which is equal to EQ. Now, actually, after the force, this charge started moving to this side. Okay, it is moving to this side. So this is the force we assume. This is the direction of the force, or we'll do it little bit. This is the force due to electric field. F is equal to EQ. And this is actual weight was suspending downward. It turned to an angle theta, which is given as 45 degree. Okay, 45 degree. Now, the tension is acting inside the thread or a rope. Now, the tension is resolved to two component. Here mg is resolved to component. Let us take it in another color. This is theta. Theta pakkat side mg cos theta. And we can think in this way. This tension is resolved to two component. We'll have it one component like this one component. So this is T cos theta. This one is T sin theta. It is clear from the diagram, T sin theta should be equal to force due to electric field, which brings equilibrium. Similarly, T cos theta should be equal to weight of the bob, mg. That's all. It is clear theta is 45 degree. This also 45 degree. When you take 45, this is also 45 degree. Anyway, sin 45 and cos 45 are 1 by root 2. Both will get cancelled. It is clear EQ will be equal to mg. Clear? And T sin theta and T cos theta, both are 45. 1 by root 2, 1 by root 2. So these two become equal. EQ equal to mg. What is E? Electric field due to the plane sheet. We know the formula. E equal to sigma by 2 epsilon naught. Electric field at a point due to a long sheet having charge density plus sigma. So we have to take out sigma out. So instead of E, we will have it as sigma by 2 epsilon naught into Q equal to mg. We wanted to take out sigma out. When you take out sigma out, sigma will be equal to 2 mg into epsilon naught divided by Q. So 2 epsilon naught mg by Q is the answer. So I think the first option is correct. Okay. 2 mg is epsilon naught by Q is correct. Okay, thank you.
Find the dimension of AB to the power of -2 from the given formula. So A is a constant, B is also constant. So you wanted to find out, this is an as usual formula. P is a pressure, V is a volume. This also volume. R is a gas constant, T is the temperature. Here, P plus, whenever it is added, இதுவும் ஒரே டைமென்ஷனா தான் இருந்திருக்கும். அப்போ A should have the dimension A by V squared is the dimension of P, pressure. So A has the dimension of PV squared. First we'll understand A. What about B squared? B squared, B is having a dimension as that of B. B is the dimension of B. What about B squared? B is having the dimension of V. B squared is having a dimension of V squared. You want to have A by B squared. A is nothing but PV squared. B is nothing but B squared. V squared gets cancelled. Pressure. Pressure and energy density are having same unit. Oh, pressure is force by area. ml t to the power of minus 2 by L squared, so that it becomes m L to the power of minus 1 t to the power of minus 2. Whereas energy density, small u, energy per unit volume, energy work done by volume, m L t to the power of minus 2 into L by L cube. Cancel it, we get the same dimension. So energy density and pressure are having same dimension, and this is the formula corresponding to energy density, dimension corresponding to energy density. Find angular velocity when 1 meter rope is pulled. Here, the mass of the body is given as 10 kg, and the radius is 0.1 meter. It's a disk. We know the formula. Whenever this type of rotation happens, we know torque I alpha is equal to R into F. Then we can able to find out alpha. Alpha is nothing but RF by I. Moment of inertia of a disk is mr squared by 2. Up here, mass is 10 kg. R is nothing but 10 to the power of minus 1 the whole squared minus 2 by 2, which is 5 into 10 to the power of minus 2. This is moment of inertia. Substitute the value, then we can able to find out angular acceleration. R is nothing but 10 to the power of minus 1 into force is 20 Newton by moment of inertia is 5 into 10 to the power of minus 2. Calculating this value, 2, 3. 1 person, 2 by 5 into 10 to the power of minus plus 2. This is alpha. 20. We can have 20 by 5. 400. Okay. Into here we can have 20 by 5. 10 to the power of minus 1. So it becomes 10 to the power of 4 into 10, because minus 1, only 1 will be there, 40. Next step. We wanted to find out angular velocity. Angular acceleration is given. It is clear. It is pulled. At that time, initial angular velocity is 0. Omega naught squared equal to omega squared plus 2 alpha theta. What is theta? It turned to an angle theta, and the distance moved is 1 meter. So it is clear S is 1 meter and its R is 10 to the power of minus 1 meter. You know, S is equal to R theta. Theta turned by this disk is S by R. S is 1 meter by 10 to the power of minus 1. Theta is 10 to the power of 10. Okay. 10 is the value. Upper omega naught squared is, this is omega squared. Omega naught squared is 0. Omega squared equal to 2 into 40 into 10. So that the term becomes omega squared is 800. Root of 800 is nothing but 2 into 400. √2 is omega. Okay, 20 √2. A Zener diode, voltage across Zener diode is 5 volt, is used as a voltage regulator. That means output voltage also 5 volt. Okay. The unregulated power supply voltage of 10 voltage is somebody. The value of the series resistance is 100 ohm. The current through the Zener diode is, so current through the Zener is 4 times current through the load resistance, IL. Okay, find out the load resistance. The question asks is load resistance available and the current through the load resistance available. Okay, here we know in the 5 volt, in the side 5 volt, and we will take this as a closed circuit and 10 voltage. This is act in opposite direction 5, which is equal to I into external resistance V1 minus V2 equal to IR. I into R is nothing but 100. But it is clear I will be equal to 5 by 100, which is 5 into 10 to the power of minus 2 ampere or 50 microampere. Milliampere, sorry. 10 to the power of minus 3 milliampere. Okay, so we got the value. The current flowing through the circuit is given to us. We know total current will be equal to current through the Zener plus current through the load resistance. Already it's given Zener is 4 IL plus load resistance, load current is IL, totally 5 IL. We can substitute this value here. I is nothing but 50 milliampere, 50 milliampere. Then it is clear IL is nothing but 50 by 5 milliampere, which is 10 milliampere. That's all. So first answer we got. So this should be the answer. This should be the answer. Anyway, we will calculate load resistance also. Output voltage is voltage across the load is equal to current in the load into resistance in the load. Okay, resistance in the load will be equal to voltage across the induction load resistance by current across load resistance. Voltage is 5 volt, we know. By current across the load resistance is 10 milliampere 10 to the power of minus 3. When it goes to the numerators, this upper the load resistance will be here, which is 10 to the power of minus 2. When it goes, the answer becomes 500 ohm is the answer. Okay, so answer is 500 ohm. That's all. Which statement is correct? Energy of ground state of hydrogen atom is equal to energy of helium in the first excited state. We'll see the formula. Energy of the nth orbit is minus 13.6 electron volt into Z squared by N squared. This is the general formula. For first case, hydrogen atom, first orbit, ground state, N equal to 1, minus 13.6 into Z squared is nothing but 1 by energy. This is the value of electron volt. Second part, energy of helium atom, the first excited state. Second case, for helium, the same formula, minus 13.6 electron volt. For helium photo, that is 2 into 2 squared 4 by N. N is nothing but second orbit in Sultana. First excited state is nothing but N is equal to 2 squared become 4 and 4 and gets cancelled. So the first option is that. So not only one, some more options are there. We'll see B. The energy of ground state hydrogen atom is equal to energy of helium atom in the second excited state. Not at all possible. First excited state is second excited state la N iron. Z squared become 3 squared 9 by, so we'll see. So this will be standard value 4. Here denominator that will be 9. So it is not possible because this is Z squared normal 4 by 9. So this is not equal. Third one, energy of hydrogen atom is equal to energy of atom is equal to the same way ground state energy is equal to lithium atom of second excited state. Okay, lithium atom, we will see the first one similar. we are checking with helium, okay? Energy of lithium. Lithium 63, okay, minus 13.6 into electron volt into here 3 squared 9 divided by second excited state means ground state, first ground state, 2, 3. That means 3 squared 9 and 9 will get cancelled. So this and this are equal. So the third statement is also correct. A and C are correct. Okay. Energy of hydrogen atom is equal to energy of lithium atom in their excited state, means first excited state. It won't be 9, it will be 4. 9 by 4 will come, so it won't match with this value. So B and A and C are correct. This is the correct answer. Which of the following is correct about image? Okay, where the image will be formed. This is another transparent media. This refractive index 1, that means free space. This is a refractive index 1.5, maybe a glass. Okay, we know if the object is placed this place, here we will get an image. This is there. It rare to denser, it bends towards. We'll take it as image. Okay, you know the formula N2 by V. When the light passing from rarer to denser, this is a formula to calculate refractive index of second medium by this distance is V minus N1 by U equal to N2 minus N1 by radius of curvature of this surface. Refraction through refracting surface. Okay. Let us substitute one by one. N2 is nothing but 1.5 by V minus N1 is 1 by U is 0.16. And here we should apply formula of, we know the object is kept in front of it. The distance is from O to R, pole to U, opposite to the incident ray. So it will become minus 1.6. This is the step we have substituted. Minus 1.6 is equal to 1.5 minus 1 is 0.5 by radius of curvature 0.2. Okay, next it will pass on. Radius of curvature is positive. Okay, from center of curvature to this is above, along the incident ray. So it is positive. Now, when we calculate this value, you can be able to bring this term 5 by 2, which is 2.5. And we'll bring this term to the other side. 1.5 by V equal to 2.5 minus, okay, this is minus or minus plus 0. Again, it will become minus 1 by 0.16. Able to find out V. V will be equal to, I'm writing here. So V will be equal to 1.5 into 16 divided by 41. We'll get the answer 0.6. We got V value. This is equal to 1.5 divided by V equal to 0.8 minus 2 divided by here, anyway, 0.32 is equal to minus 1.2 divided by 0.32, which is nothing but, when you cross multiply the value, V will be equal to 1.5 into 32 divided by 120 will be minus 0.4 centimeter is the answer. Okay, this term you can have it as pi by 2, and they have calculated pi by 2, and the calculation is made like that way. Okay, so the answer is 4 centimeter. Minus 4 centimeter is coming. So 4 centimeter on the left of the surface. Because this is minus 4, so that image will be formed in front. So that will be the answer. Okay. Your cell phone has a rating 4.2 volt and 5800 milliampere. Find the energy stored in the cell phone of a battery within 1 hour. Okay. Power that can be given to the cell phone is voltage into current 4.2 into 5800 into 10 to the power of minus 3. So we know this value, voltage into current, we know this value, power is there. Power is equal to, ஆனால் நமக்கு வேண்டியது energy stored, power into time is the energy. Energy, time is 1 hour, so power is 4.2 into 5.8. Time is, the answer they have given is kilojoules. So first we will find out in joules. So 5.8 into 60 into 60. 1 hour is equal to 60 minutes into 60. When you calculate these values, you will get 87696 joule, which is nothing but 87.7 kilojoule we can write. 87.7 kilojoules. Okay. Displacement equation of SHM is given. X1 equal to root 7 sin pi t. X2 displacement equation for the second way is 2 root 7 sin pi t plus pi by 3 is given. Phase difference between the two ways pi by 3. Find out maximum acceleration of the resultant SHM. Okay, this question we can able to find out maximum acceleration amplitude equal to a omega square. First we should find out omega. We can able to find it out very easy. Omega is nothing but 5. That is, it won't be a problem for both cases. We wanted to find out resultant amplitude. Resultant amplitude is equal to root of a1 squared plus a2 squared plus 2a1 a2 cos pi by 3. Here the phase difference is pi by 3. Cos 90 is 1 by 2. That we can able to cancel 1 by 2 and 2. Now we will substitute 1 by a. A1 root 7 the whole square is 7 plus 2 root 2 4 into 7 plus multiplying root 7 into 2 root 7 into 2 root 7. The amplitude become 7 plus 28 plus root 7 into 7, 7 into 2, 14. Taking square root of this value is here 35, 45, 49. Root 49. Resulted is 7. Amplitude we got it 7. So 7 meter. Amplitude, acceleration amplitude will be equal to a is nothing but 7 into, here we wanted to find out omega squared, which is pi squared 25. 7 into 25 is 175 meter per second squared is answer. Angular separation between second maxima of left hand side of central maxima and third maxima of the right hand side of the central maxima is 30 degrees. It's very clear. This is zero order maxima. On the left hand side, second maxima, and right hand side, third maxima. The angular width is, you can take it as angular width. Angular width is given as 30 degrees. We know this is 2 beta and this is 3 beta, where beta is bandwidth. So 5 beta is the width. And the wavelength is also given. They asked beta, bandwidth. That is distance between the two slits is asked. Small d is asked. Okay. We know the condition. S is equal to R theta. You have to remember this formula. S is pi beta. R is nothing but capital D, this distance. And theta is 30 degrees. 30 is nothing but pi by 6. Okay, we'll substitute the value. Here we wanted to find out uh, 5 into lambda capital D by small d is the value, which is equal to d into pi by 6. Capital D gets cancelled. We wanted to find out small d taken out. Pi into lambda by into 6 by 3.14. So here we wanted to find out 3.14. We wanted to find out d. Here they have given lambda, but d will be equal to 5 into lambda is nothing but 628 nano to the power of minus 9 into 6 divided by 3.14. We know this is goes in 2 times. 6.28 means 2 times, it's 200. So you can write 5 into 6, 30 into 2 into 10 to the power of minus 7, which is nothing but 60 into 10 to the power of minus 7 meter is answer. Or in other words, 6 into 10 to the power of minus 6. So give the answer in micrometer. The answer is 6 into 10 to the power of minus 6 meter. Nothing but 6 micrometer is the answer for this question. A car travels a distance x with a constant speed v1, which is 10 meter per second, and then it travels further 3 by 2 x distance with a constant speed v2. Okay, the average speed during the entire journey is 50 by 7 meter per second, and the value of v2. We wanted to find out v2. It's given clearly. First, it travel a distance x with a velocity 5 meter per second. Then it travel 3 by 2x, it's greater than x, 3 by 2x with a velocity v2. Its average velocity is given. Find out the value of v2, right? Simple question. Average speed, constant speed. So average speed equal to total distance traveled time taken. This is a formula. First, it traveled distance x. Then it traveled distance 3 by 2x by time taken. V1 equal to distance by time. So here T1 plus T2. T1 is x by V1, which is x by 5. T2 is nothing but distance traveled is 3 by 2x by V2. This is second case. Okay. Now we'll substitute the value. Average distance is equal to, we can take 2x plus 3x by 2, 5, 2x plus 3x by 2, 5x by 2. Okay, 2x plus 3x by 2 divided by T1 x by 5. We can take x common, 1 by 5 plus 3 by 2 V2. We wanted to find out V2, which is equal to average distance is 50 by 7. Okay. We know x and x can be cancelled. Okay. Right. Average velocity is average velocity is 50 by 7. It is given 2.5. So when you cross multiply, it will become 50 by 7 into 1 by 5 plus 50 by 7 into 1.5 by V2. This is denominator V2. Okay, equal to 2.5. Here this will become 10 by 7, bring to the other side, 50 by 7 into 1.5 by V2 equal to 2.5 minus 10 by 7, which is 7 into 2.5, 17.5. 17.5 minus 10 by 7. This 7 and this 7 can be cancelled. The V2 will be equal to 50 into 1.5 divided by 7.5. Here 75 divided by 7.5 will give you 10 centimeters answer. A monoatomic gas A has only 3 degrees of freedom. Okay. It's a monoatomic gas, it has 3 degrees of freedom. While the polyatomic gas, another gas, let us take it as B, has 3 translational, 3 rotational, plus vibration mode means 2 degrees of freedom for vibration mode. So it is 7, 6, 3 plus 3, 6 plus 2, 8 degrees of freedom. Okay. We know for adiabatic process, the ratio of polyatomic gas, value of n integer. This is gamma. Ratio of adiabatic expansion means gamma. Gamma for A is 3 degree of freedom, Cp by Cv. We know for monoatomic gas, Cv equal to 3 by 2 R. Cp is plus R, 5 by 2 R, which is 5 by 3. Gamma for this adiabatic exponent means ratio of gamma the seed capacities. For second gas is Cv is nothing but 8 by 2 R, which is 4 R. Cp is 5 R. This is 4 R. Cp by Cv is 5 R by 4 R. So we wanted to find out this expression. This is 5 by 3 and this is 5 by 4. 1 divided by 2 code, which is 5 by 3 divided by 5 by 4. 5 gets cancelled, which is 4 by 3, which is equal to 1 plus 4 by n. So 4 by 3 minus 1 equal to 1 by n. Okay. 4 minus 3 by 3. 1 by 3 equal to 1 by n. So n will be equal to integer value is 3. That's all. The equation of wavefront of a light is given by x, y, z constant equal to constant. The angle made by the direction of the light propagation with x-axis. Okay. The angle made by the here it is clear. X, Y, Z is three coordinate. X, Y, Z. All are, let us assume at 1, 1, 1. So what is the resultant? Resultant will be equal to root of 1 square plus 1 square plus 1 square is the resultant, which is equal to root 3. Okay. We wanted to find out the angle from x-axis. Resultant maybe in three-dimensional, that angle is theta. Okay, from x-axis. So always we'll take x-axis means adjacent side cos theta. Cos theta will be equal to adjacent side by hypotenuse. Here the value is, let us take it as x. So x is the adjacent side by hypotenuse is root 3. That's all. So x can be taken as 1 no, but theta will be equal to cos inverse of 1 by root 3 is the answer. Okay. Cos inverse of 1 by root 3 is cos inverse of 1 by root 3 is the answer. Okay. That's all.